Hello everybody, welcome to another video, and in this video I will show you how the application layer data looks like and how the encryption layer looks like. So let's just get started with sniffing, and then we will bring our devices online. So if we have a look at this, OT dataset active is fine, OT dataset active is also fine. So let's bring these online. So if we config up and then OT thread start, and then we do OT config up and OT thread start. I just started them along together, so let's see what happens. I haven't done that in a while, so let's see what happens, who becomes the leader and who becomes the child, or how do they resolve this situation. Okay, so both of them are detached. Maybe one of them becomes okay, so this one becomes the child, and okay, so device 2 became the leader and device 1 became the child. Yeah, that's all right. So let's send some UDP packets. If you remember, OTCLI provides UDP commands, so we would do is OT UDP open. It's already open. Okay, so maybe from the last runs I will just look at my notes here. So then we do a bind. Probably the binding is already also done. So 1 2 3 4 done, and then probably here also it's already done. Okay, so UDP is already open, and then we do OT send, and here we would have to OT IP address. Let's use mesh local address, and then here the port number, and then the message hello. Okay, so something is invalid. OT send, yeah, OT UDP send. Let's OT UDP send, and you see here the terminals are breaking characters a bit, so let's do it again. OT UDP send hello, and this guy received it. So we did send some packets. Let's just stop this here, and we are not sniffing anymore. It's so here, if you look like port 1 2 3 4 is here. If you want, you can also apply filters. So in the IPv6, since port is UDP, destination port 1 2 3 4, so let's apply that as a filter, and now we have the packets that we are interested in. So the first one is again yeah, a hello text sent from one device to another one. And how do we know where the encryption is? Let's there are two ways, I guess you know already. One is the presence of this auxiliary security header. So if you remember, this header was in the MLE, was also using this header. That's exactly the same header, and it uses the same way to encrypt and decrypt. So this header is now at the link layer, and that means all the information is encrypted on the link layer. And yeah, here if you look at here, the data here is here the data is this one, hello, and here also that's the data. And let's just, to be sure, let's disable the encryption and decryption and see what happens. So IEEE 802.15.4, and I will let's just remove this key. Okay, and now we don't even see that because it is not UDP anymore. So currently let's filter out all the traffic that is MLE. So apply the filter, not selected. So now we are left with the traffic which is just IEEE 802.15.4, because that traffic is anything above that is encrypted. So if you look here, these are the acknowledgements. So ends apply filter and not selected. So we don't want the acknowledgements as well. So now what we want is source destination, some broadcast message. We apply probably not, that is not also not what we want. So this is not also the broadcast. So we have B001, B00, B00, B001, and some communication between 200 and B00, whatever. But here you see that there is the security header, and this information is now encrypted at the link layer, and we are not able to see that. Let's try. So if we leave these filters now, I think we should be able to, if we set the key, we should be able to see these packets, and the filters would not become invalid because those filters would still exist if the data is decrypted. So let's OT dataset active. Let's get our network key, and then in the preferences, what we can do is set it again. And again here. And now we see that some of the packets is co-app packets for, yeah, whatever the task, whatever they were doing. And then there's a 1, 2, 3 packet here as well, and another one here as well. So our packets are also included here. And you also see that the co-app packets are also then encrypted at the link layer. So the MLE is not encrypted at the link layer, it's encrypted at the MLE layer, you can say, and then the co-app and the rest are encrypted at the link layer. So the MLE establishes link layer security, and then we use these higher level protocols to then use those secure links to communicate. So here this is the link. If you look at the data here, then here you see the hello. If you look at the frame, you don't see, because now this is just the encrypted raw data, and then here it's still again 6LoWPAN that makes the decryption. So anything above then the 802.15.4 is then the result of decryption and then detection. So this is how this encryption works, and I hope this was enough. And in the next videos, I will go a bit more into details about these IP version 6, so that these are a bit easier for you guys, because I think now you guys would probably be confused with a lot of these. Yeah, with this, see you in the next video.